It's my birthday, and this place is rocking. That's not true. It's just me by myself on my birthday. However, I do have one of my presents here, one of my gifts, wrapped in Christmas paper. It's actually my only gift that I bought for myself. But here it is. Now, before I open my gift, I just kind of want to go over a few things with you real quick about what this is, this particular shape, this figure. And this figure here is actually called three-dimensional solid. It is one of several types of solids. And I guess if you have a friend or something that ever comes to you and says, hey, can you do me a solid? I guess perhaps you could just give them one of these. So anyway, it's three-dimensional, which means we say three-dimensional because it crosses or moves, spans over 3 dimensions. We'll take, this is 1 dimension, so we can measure it in this direction. This is another dimension, we can measure it in this direction, or we could also measure it in this direction. That's our third one. So we have a figure here in which we can measure 3 different dimensions or 3 different directions of it, which is the reason we call it a 3-dimensional figure. Now, not only is this just considered a 3-dimensional solid, it's also considered something more specific. It is actually called, and you probably can recognize this by each of the faces, it is also called a rectangular prism. Now, it's rectangular because each of the sides represents a rectangle. And also squares, but we're going to get to the squares later. I'm going to save that one for another video. And the reason that it's called a prism is because it has 2 polygons that are opposite and congruent to one another. So if you take one side and then its opposite side, they are both polygons and they are parallel and congruent to one another. There are some other characteristics or properties about this particular gift. Before I open it, I want to share with you. How many sides does this have? Well, it has 6 different sides. Each side is called a face. So we could say this has 6 faces. It also has these corners. And it actually has 8 of these corners. These are called a vertex or plural vertices. So it has 8 vertices and 6 faces. And the last item I wanted to demonstrate to you or show you is in between each of the vertices is this segment. This is called an edge. So in between each of the vertices is this segment, which is called an edge. A rectangular prism will have 6 faces, it will have 8 vertices and 12 edges. I'm a curious person by nature, so I would like to kind of figure out how much paper it would take to wrap my gift. Normally, I'm a very conservative person. In fact, usually most gifts that I wrap, I keep them in the Walmart or Target bags and just tie the handles together. But this one I actually wrapped for myself, and so for this video. And what I would like to do is figure out what is the minimum amount of paper that it would take to cover this. Now, we usually go a little more than that when we're wrapping to make sure that we're covering every part of it. So we'll cut a little bit more than that, but I just want to know, I want to try to figure out what is the minimal amount, like what is the lowest amount of wrapping paper I could get away with in covering this box that contains my gift. So what I'm really trying to find is how much paper it would take just to cover the outside area of this entire box. In other words, how much paper would it take to cover all the faces of this present, this gift, this box? Now, one way we could do that is basically I could find the area of each side and then just add the sum of all those areas. For instance, I could find the length and width of this particular side here. So I can measure its length and its width. And then I would know the area. I would multiply them together, the length and the width, and I would know the area of this one side. But since this is a rectangular prism, I will know that its opposite side has the exact same area. They are congruent to one another. And I could do the same for this end of the box, this side of the box. I could measure its length and its width. I would know the area, and it would be the same as the area over here. So these two would be congruent to each other. And then I could do the third side and the same way, and then it also has a congruent side. And I could add those two together. So basically, I have two of every side. And I actually can use that to kind of reduce the amount of calculations that I have to do. The formula that I'm going to use for you is 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Now, what that means is I'm just going to gain 3 measurements. I need to get a length, a width, and a height. Once I've obtained those 3 measurements from my box, I can apply them to the formula, substitute the variables with those values, and then I can determine the entire surface area of this box and how much wrapping paper it would require. Now, I'm going to be measuring in inches. So here we go. Okay, let's measure. So the first thing I'm going to measure is across here. We'll call this our length. So we have a length of about 12 inches. And then the next one I'm going to do, I'm going to call it my width. I'm going to measure this one, and it's approximately 7 inches. And the only other dimension I have left is from top to bottom, or the height. And this is about 6 inches. So we're looking at a length of 12, a width of 7, and a height of 6. So this diagram shows that I have a length of 12, a width of 7, and a height of 6. To calculate the surface area of this rectangular prism, we need to replace each of the variables with one of the values that we obtained. So we replace each L with the 12, each W with the 7, and each H with the 6. We then simplify this expression. We end up with 396 square inches. So the total surface area of this package is 396 square inches. One of the questions I most often get from students would be, well, which one is the length, the width, and the height? Well, with a rectangular prism, it doesn't necessarily matter. It just depends on the type of rectangular prism it is and how it's sitting in relation to other objects and also itself. So when you're trying to calculate the surface area of a rectangular prism, it really doesn't matter what you identify as the length, the width, and the height, just as long as you have one measurement for each of those dimensions. So you need one measurement or value for the length, one for the width, and one for the height. Just don't, I guess the most common mistake I see is someone might measure the same thing twice, but call one of them something else. So just be careful when you're measuring a rectangular prism that you don't move the box. One other thing I would like to do before I open my present is I would like to figure out the volume of this box, of this gift. So let's take a listen. Not really hearing much. It has a very low volume. I maybe could hear some of the ocean, but that's about it. Now, by volume, I do not mean the level of sound. What I'm referring to is the capacity. How much empty space is in this box? Well, hopefully there's not much empty space at all. Hopefully it's full of my gift. But if this were to be an empty gift box, how much space would there be inside this box? How much available space would there be? Now, in order to do that, I really only need the 3 measurements I already came up with. I need my length, my width, and my height. And we've already obtained those. We came up with, I had a length of 12, a width of 7, and a height of 6. I'm going to use those same three values to determine the volume or capacity of the inside of this box. To calculate the volume of this rectangular prism, we simply replace each variable with the values we obtain from the box. We replace the L with 12, the W with 7, and the H with 6. And then we multiply, simplifying the expression to 504. So the entire volume of this rectangular prism is 504 cubic inches. Okay, it is time. The moment that I've been waiting for. I can't remember what I got me. You know, students will often ask, well, why is it that we use a squared or a 2 when representing the surface area? Well, very simple. We are flattening, we're actually measuring the rectangular prism as if it was flat. So all the area of a rectangular prism in a flat state or flat form. So really, ultimately, we're just measuring its length and its width. The two different measurements are the lengths and the widths of the surface area that we're trying to find. Now, also, they will say, well, Mr. Kaufman, why do we use a 3 to represent the volume? The 3 being cubed. Well, it's simply because we're measuring 3 dimensions to determine the volume. We're measuring the length, the width, and the height. So that's where the 3 comes from when we use cubed for the volume. One other thing I would like to show you, I'm going to take the box that I received my gift in, and I'm going to break it apart for you. I am going to unfold it and lay it out flat. So I'm starting with a 3-dimensional rectangular prism, and I'm going to flatten it out on the table into a 2-dimensional form. And show you what that looks like. So here we have what's supposed to be a flat 2-dimensional representation of a 3-dimensional figure. And this is what it looks like. Now, I don't know if you're already familiar with this, but this is what, well, what we call this, it starts with an N and ends in et. That's right, it's a net. This is a net of a rectangular prism. Now, a net is, all it is a 2-dimensional representation of a 3-dimensional figure. So this is what the rectangular prism would look like if it was laid out completely flat.